sorry, BA minus BB equals these values. G is equal what?
If you want also, you can substitute the gamma by rho G, then
This one?
G is equal to 32.2.
We can cancel this one.
by rho G.
We can cancel with gamma to remaining rho.
Right.
Because gamma is rho G. Correct? Cancel G with G. Remaining is rho. Means 10 square divided by 2 all times 0.2. Now we can get BA minus BB. And the unit for this one is pound per feet square. But actually for a choices, even if it is a British also, it is not default for pressure is coming pound per feet square. Or what is the default? The default for pressure unit is coming by BSI. The default for the units at the end is BSI. So in this case, what's the idea for solving? After you get the answer here, pound per feet square, just divide it by, we can change here, pound per feet square, because this one used a lot. To change it to BSI, just to divide this answer by 144. And if you have BSI and you need to change it to pound per feet square, multiply by 144. Please don't forget this conversion. This conversion solved many problems. So don't change it from British to SI unit. If you know this conversion, you can solve it many problems by British. Because if the problem is starting by giving pressure, normally pressure given by pound per feet square, sorry, by BSI, and other units is by feet square. It means to continue British should be changed from BSI to pound per feet square, from BSI to pound per feet square. So just to multiply BSI times 144. In other hand, if the required pressure, we get it by pound per feet square, but the choice is normally by BSI. In this case, just pound per feet square divided by 144 to convert to BSI. This clear?
One more time, that 0.2 is the value for gamma, right? So gamma divided by G. Gamma is equal to rho G.
Yes, gamma is equal to rho G.
And
this one is rho
divided by gamma divided by G is equal to rho. Correct. Gamma is equal to rho G. Yeah.
Yes, cancel this with this.
Yeah. But the value is gamma is equal to 0.2, right?
This rho density 0.2 pound per feet cube.
This is it's rho only. Okay.
Yes, actually for British units, this is what I see, but I don't know the reason. Sometimes consider gamma pound per feet cube, and sometimes use it as a rho in the same time. I don't know how come for these two the same, but I see this case used a lot for many problems, for especially for British unit. Use it, for example, as you see here, for calculation of the Q, just divided the mass flow rate divided by the rho to get the Q direct.
One more time.
Again, some of the problems, as you see here, we have gamma, for example, 0.2, okay?
Yeah.
But we have some confusion for some problems for bridge, okay? Sometimes is given density or sometimes given rho, but the value, it is different. What meaning, for example, given gamma, for example, for water 62.4, and sometimes given rho 62. If you time or multiply rho times g, you can't get it gamma direct. It means in British, it's considered gamma as a rho. I don't know for this issue. I searched for this one to understand, because sometimes it's used gamma, sometimes used rho as the same meaning.
Okay.
Okay.
Yeah.
Today we will study this in details for the Bernoulli equation. Okay.
Okay.
Please, this one don't forget for this conversion. Very important, this one.
Yes.
Finished? Okay,
Yes.
back to presentation. Okay, already we have a screen here.
Yes.
Okay. We're starting for this session by types of fluid flow. Types of fluid flow. Actually, the flow classified in different categories. You see me?
Yeah.
Or screen?
Yes, it's clear.
Screen?
Yes. Yes. Everything okay.
Okay. Actually, we classify the flow by different categories. First, we classified to steady and unsteady. Also, we classified as a uniform and non-uniform, and laminar and turbulence, rotational and irrotational. How many directions or dimensions for the flow? 1 dimension, 2 dimensional, 3 dimensional, compressible and incompressible. One is not mentioned here, but incline the slide. Viscous and inviscid flow. Okay. These categories is separate categories. It means when you're going to classify, the flow should be classified as steady and unsteady, and also should be classified as a uniform and non-uniform. This is totally different. This one is different to the other one. Okay. The big confusion for this classification is steady and unsteady and uniform and non-uniform. Why? The velocity vary with 2 parameters. What is these 2 parameters? Velocity vary with time and displacement. If the velocity need to study with time, should be the displacement constant. And if you want to study the velocity with displacement, should be the time is constant. Okay, don't study two variables together, one by one. If you study the velocity with time, the response of velocity with time, it means you study the flow and classify the flow as a steady and unsteady. Okay?
Yeah.
Okay. Here's some animation. Okay. This velocity is vary with time and displacement. If you study the velocity with time, it means you study the velocity with time. What is the rate of change of velocity with time? Okay. If this studying not changed, it means this one is steady. But if this one changed with time, it means this one is unsteady. For example, if you have for unsteady, we have pipe like this. Okay, you study the flow here at x equal x1. What happened? What is the velocity here? The velocity at time equal t1 equal tau. But at time t2, this equal to tau plus 4. At time t3, this equal tau plus 7, and so on. It means in this case, the flow on the same position with no change in displacement. This time, is it changed or not? The velocity changed with time or not? Yes, it changed with time. First start by tau, after some times is tau plus 4, and so on and so on. It means the rate of the velocity crossing this cross section not constant. It means in this case not equal to 0. It means unsteady. But in other case, if this time with time 1, time 2, at any time we study is the same, it means this equal to 0. It means this one is steady. Go to the other one, uniform and non-uniform. Uniform and non-uniform. For uniform and non-uniform, you study displacement. It means other variable shall be constant. It means we study at now, for example. Now, it means time is now. No, we study after 5 minutes. It means at time after 5 minutes, exactly at 5 minutes, I will check the velocity. Check where at different position, means partial v, partial x may be equal to 0 or not equal to 0. For example, for the same, this one, the velocity here, this at x1, but here x2, here x3. Now we study at time equal what? Time t1 and time t2 and time t3 and so on? No. Should be fixed the time. It means I study these 3 position at time t1. What is the velocity on the same time? Instant. Time here, velocity here take shape. Here is different because the pipe is different shape. It means the profile for the velocity expected to be changed. Also here changed. It means the velocity with distance, it changed with displacement. It means not equal to 0. It means non-uniform. But in other case, we have pipe like this. Cross section here is the same. Cross section here is the same. Cross section here is the same. At time t3, all at time t3. What is the velocity here? Something uniform like this. Here, something uniform like this. Here, something uniform like this. It means the velocity x1, x2, x3, velocity profile the same on the same time at different position. It means partial v partial x equal to 0. It means this uniform flow. Any question? Any question? Any question?
In the first explanation, the first drawing, you mentioned about tau. What is that factor? TA.
Well, tau is a factor time. Just a time, for example, t1 at 4 seconds. This one 4 by 4, it means 8 seconds. This 4 plus 7, it means 11 seconds. Tau, it means time.
Okay.
Okay. Any question?
In first case, sir, the velocity, first case, can you explain first time?
This one?
Yeah, first case, steady. Yeah.
Yeah. For steady and unsteady, just to study the velocity with time, but should be studied this velocity with time at same position, not like this, same position. For example, if we applied here, for example, I need to apply here this is steady or unsteady. To check that, I check here. I select this position. And I check the velocity profile in this position with time. With time, but still the position not change. The profile here at now after 5 seconds, 10 seconds, 20 seconds, 30 seconds, 1 minute, and so on. Profile not changed. It means this is steady. But if the profile, if this profile, it changed with time, for example, this is the shape at time equal 1 second. After I see the profile like this. Increases slightly some values. After 10 seconds, it's slightly like this. It means the increased. On the same position, it means the velocity changed with time. Velocity changed with time. The profile not constant here in the same position with time. It changed. Maybe the flow not continuous. Maybe the flow decrease and increase, something like this. Okay? Clear?
Hello.
Yes, sir, clear.
Hello.
One my question, in steady flow or unsteady flow, is it related to the velocity or related to the quantity of liquid?
None of velocity.
Velocity.
Yes. The
Okay.
main variable here is velocity. You study the velocity with time and you study the velocity with...
Okay. And in uniform flow, then there is
uniform
velocity.
flow, you study with displacement. A different position.
Different position. Yes, yes.
Yes. But should be the time constant. It means this pipe now I will check the velocity with different position now for all position all the same. Okay?
Okay, okay.
That's it. Going to next. Laminar and turbulent. Laminar and turbulent. If the flow is going through like this laminar or turbulent? Flow, all flow going like this. This laminar or turbulent?
Laminar.
Laminar. if the flow going like this,